Okay, so let's go over some questions, or all the questions from the review. Okay, so you should already see the solutions posted, but this is just going to give you an idea of how you should go about it. So you really shouldn't be watching this video if you haven't already worked through the review yourself. All right, so for number 1, it's been a little while, but when we talked about absolute extrema can only exist at a critical value or at an endpoint. That's our only options. So first, let's find out where the critical values are. So the derivative would be 12x cubed plus 12x squared, and we'll set that equal to 0. Okay, it will be something you can factor. So this is 12x squared that they have in common. So if you factor that out, you're left with x plus 1 equals 0. So I have 0 and -1 as critical values. Now before you go plugging these in, you do need to verify that the critical values are actually in your interval, but notice 0 and -1 both fall in our interval, so we're good there. So you're going to find h of 0, h of -1, but also h of the endpoints. And you're going to find out what all of these values are, and then you're going to choose the highest or the smallest one. So highest being the max, smallest being the min. So this is 0, -1, 16, 17. Okay, you use your calculator for that. So the absolute max is going to be the point -216, and the absolute min in that interval would be -1, -1. Okay, so number 2, same kind of thing, it's just the derivative's a little harder to find. So 3x to the 2/3 minus 2x on the interval from 0 to 3. Okay, so first let's find the derivative and set it equal to 0. So this would be 3 times 2/3 x to the -1/3, right? Bring the power out to the front, subtract 1 from the power, minus 2 equals 0. So first you're going to have a little bit of a challenge actually figuring out what this is going to be. Okay, so notice these are going to cancel, the 3's cancel, and you end up with 2 over the cube root of x minus 2 equals 0. Okay, so the easiest thing to think about here is, rather than trying to solve this, which you can do by the way, try to think about what this would need to be. Like, what would x need to be so that this would work, right? So that you'd end up getting 2 minus 2 equals 0. Okay, so you can do a lot of work, or you can just notice that, hey, if x were 1, then I'd have 2 over 1 minus 2, which is 0, so that will work out. Okay, so this is my critical value. So I need to find f of 1. Notice 1 is in the interval, so I can go ahead and check it. If I had a critical value that were not in the interval, I would just throw it out all together. Okay, so if you plug in 1, you're going to get 1. If you plug in 0, you're going to get 0. If you plug in 3, you don't get something that's a whole number, but you do get approximately 0.24. So notice then the absolute max is the highest one. So the absolute max is 1, 1. And the absolute min is the 0 term, 0, 0. Okay, so let's look at number 3. All right, so we're trying to maximize or find the maximum monthly profit, okay, and we have a profit equation, right? So if we want to maximize this equation, then the maximum can only occur at an endpoint or at a critical value. Okay, so we're going to find the derivative, which is -20x plus 1760. Set that equal to 0. Okay, and we're going to get x equals 88. So you do need to test this. This is a critical value. But you also do technically need to test the endpoint. So you need to test 0, and then we'll test 88 as well. Notice there's no high endpoint because you could just keep kind of renting more and more units basically. Okay. Actually, I guess we could test 100. So in this one, we do have a cap at 100. Okay, so that's kind of important to note there. So if we plug in 0, we're going to get -50,000. If we plug in 88, we're going to get 27,440. And if we plug in 100, which honestly, if you were using common sense, you might think, well, hey, I should rent all the apartments, right? I'll probably make more money the more apartments I rent. But in this case, you end up getting a negative quantity. Actually, not a negative quantity. Hang on a second. So let's go ahead and punch it in. I'll show you on my calculator. So negative 10 times 100 squared plus 1760 times 100 minus 50,000. So you end up getting not a negative amount like I said before. So you end up getting 26,000, but it's not the same as this, right? It's not as large, okay? So the max is right here. So you will rent 88 units. And the profit, if you do that, will be a maximum of 27,440. So actually, in this case, they would be better off to leave 12 units empty. Okay, they'll make the most profit for renting exactly 88 units. Okay, so let's look at number 4. Find the dimensions of a rectangle of area 144 feet squared that has the smallest possible perimeter. So if you have a problem that involves shapes of some kind, I would suggest drawing a picture. So we've got length times width. We don't really know the measurements, okay, but we do know that area is length times width, and we know that that's 144. Okay, we know that we're trying to maximize or find the greatest perimeter, and the formula for perimeter is 2 length plus 2w. So remember, our format for these, it's been a little while, okay, but our format for these is get an equation with one variable and then take the derivative and set it equal to 0. Notice here we have 2 variables, so that's not going to work. So what we're going to have to do as soon as we can is we need to solve for one of these variables. So I'm just going to divide by L. So notice I've got W equals 144L. I could have also solved for L if I wanted to. But now I'm going to plug this in over here. So now I've got that the perimeter is 2L plus 2 times 144 over L. Okay, so let's go ahead and kind of clean that up a little bit. So I've got 2L plus 288 over L. But if I'm going to take the derivative of this, which I want to, then I probably need to rewrite this as 2L plus 288 L to the negative 1 power so that I can easily take a derivative of it. So now let's do that. The derivative would be 2 minus 288 L to the negative 2, and we're going to set that equal to 0. So 2 minus 288 over L squared equals 0. Okay, so here you're going to have to do some algebra work. Okay, there's no way around it. You've got to do some algebra work on this one. So my suggestion would probably be to maybe move this term over. So this will give you 2 equals 288 over L squared. But then you're going to have to get the L squared out of the denominator. So I'm going to do that by multiplying by the denominator. Notice over here, that's going to get rid of this. That's going to leave me with 2L squared equals 288. But now I can divide by 2, and notice I'll get L squared equals 144, but I don't particularly want L squared, right? I actually want L. So what's the square root of 144? 12. So now you have to come back up here. So notice that the length is 12 feet. So now you have to go back to your original formula, and remember the area was 144. So the width in this case would also be 12 feet. So always make sure you're answering the question. Notice I asked you for the dimensions, right? Actually, I asked you for the smallest possible perimeter, right? So actually, I haven't quite answered the question yet, so I really shouldn't have circled that. Okay, so the smallest possible perimeter would be 2 times 12 plus 2 times 12, or 48 feet. Okay, and perimeter is not feet squared, it's just feet. Alright, so on the key, I think I said, oh, I did say find the dimensions. Well, anyway, so I need to read my own writing. Find the dimensions of a rectangle. So the dimensions were the correct answer, but if I asked you for perimeter, you would just plug them in like I did there. All right, so number 5, we did a problem really close to this. Okay, so we have a box, or sorry, a square of cardboard or something, and we're going to cut out sections and then fold up the corners, and we don't know how big these sections are. So we're going to call each of the measurements X. But we do know that we started off with measurements of 10 inches. Okay, and we're trying to find the maximum volume. The problem with trying to maximize volume as it is that volume is length times width times height. I'm supposed to have one variable and I have 3. Okay, so that's not really going to be helpful when I get to find derivatives or get to finding derivatives. So I need to figure out an expression for the length, the width, and the height that maybe involves another letter X. Okay, all of them. So notice the length would be 10, and then we're going to cut off 2 X's, one on this side, one on this side. Same with the width. We're going to start with 10, and we're going to cut off 2 X's. And if you fold the box up, the box will be this height. It will be X tall. So the volume is 10 minus 2X times 10 minus 2X times X. So I'm going to let you do all the work for this, but you need to make sure you know how to FOIL. But if you FOIL this out, you're going to get this back again. So I almost always have someone try to factor this. Well, if you try to factor this, you're going to get right back here, okay, because we just came from there. So what you actually have to remember to do is find the derivative and factor that. So it's 12x squared minus 80x plus 100, and you set that equal to 0. So what I would do is pull out a 4 first. Okay, it'll make factoring easier, but I'm going to let you figure out the factoring parts because we're way, way, way past factoring. But if you factor that, you will get what appears to be 2 answers, but only one really makes sense. Okay, the reason 5 is going to get thrown out here is because if we cut 5 off of this side and 5 off of this side, we've cut our whole cardboard to shreds, right? We have nothing left to make the cardboard with. So we know that X is 5/3. I think in this one I asked you for the dimensions. Okay, so you would go plug this in up here. You're going to get 20/3 here. You're going to get 20/3 here. And then you're going to get 5/3 here. Okay, so the volume is going to be all of these things times each other. So if you're looking for exact answer, it would be 2,000 over 27 inches cubed. But the approximate answer is 74.07 inches cubed. So your strategy, no matter what the problem is get the equation to have one variable, find the derivative, set it equal to 0. Okay, that needs to be your strategy for any and all questions that look like this. They're called optimization problems, where you're trying to find the optimal or the perfect scenario. All right, number 6. An apple orchard has an average yield of 36 bushels of apples per tree if the density is 22 trees per acre. If each unit increase in tree density, for each unit increase in tree density, the yield decreases by 2 bushels a tree. How many trees should be planted to maximize yield? So, yield is going to be how much are you able to harvest. So you need bushels per tree times number of trees per acre. Okay, if you know those two things and you can multiply them, that will give you what your yield is. Okay, so the trick here is to let X be something that could be related to both of them. Okay, so we're going to let X be the number of trees per acre above 22. If you remember right when we did this way back when, so you can go back and watch the video, it was like a travel agency problem, but it was the same exact format. Okay, it was like number of passengers times the rate of each passenger, so you can go back and look at that question too. All right, so let's come up with a yield. Okay, so the bushels per tree is going to be 22 plus some unknown quantity. Okay, we started off with 22 and we're adding some number to that. Okay, but when we do that, we reduce the number of trees per acre by 2. For every one we increase, the one we decrease the second amount by 2. So if you FOIL this, you will get this equation. And notice now we have an equation to find the derivative of. So as weird as that looks, this is just the derivative of the yield, right? The derivative of the yield would be negative 4x minus 8. So if you solve this, you get x equals negative 2. Okay. In other words, we actually need to subtract 2, right? So 22 plus negative 2 would be 20. Okay, so that would, notice that would give you the bushels per tree, right? Let's look at my key. Yeah, so 20 is what you end up getting here. Technically, that's the bushels per tree. If you wanted to know what the number of trees per acre was, you'd plug in negative 2 here. Okay, so you'd actually get 40 trees per acre there. Okay. Okay. So that's the end of derivative for a while, because now we're going to talk about antiderivative for quite some time, or integrals. So you definitely need to make sure you can transition between the two. In other words, can you switch between derivatives and antiderivatives without getting too confused? Okay. So the antiderivative power rule, remember, is bring the constant down and then do 1 over the new power x to 1 more power. Okay, so you add 1 to the power. Here, bring the constant over, add 1 to the power, multiply by 1 over that power. But then the antiderivative of e is just itself. And then don't forget your plus c on your indefinite integrals. So that's what you should get on the first one. Okay, number 8, I'm just going to go ahead and rewrite this. This would be x to the 1/3 minus x to the 1/2 plus 4 dx. Okay, remember the notation dx should always be there with integrals. So again, I'm just going to do the power rule. So I'm going to add 1 to the power and do 1 over that new power. So 1 over 4/3, x to the 4/3, okay, minus, add 1 to this, and you'll get 3/2, x to the 3/2, and then plus 4x. Don't forget your plus c. Okay, do clean this up though, so fractions on the bottom will be flipped. And remember, if you really wanted to check yourself, you could take the derivative of this guy and you would get this back again. Alright, so notice, I didn't need to use substitution or anything weird like that. So let's look at number 9. So again, I'm going to rewrite this one as 4 times 1 over x dx. So I'm going to move the constant over. Hopefully you recognize this as one of your special cases. Okay, so this is going to be the antiderivative of 1 over x is the only one that can't use the power rule. So it's going to be 4 times the natural log of x. Okay, and then plus c. So starting with number 10, you might notice that it looks like there are 2 parts to this. So I have negative 7 ln of x, and then I'm going to do times 1 over x dx. So I'm separating these parts out. This is classic substitution method, or we would want to use substitution method because I have something and its derivative. So I'm going to let u be ln of x because the derivative of that is 1 over x dx. Okay, so let's talk about what I have. Notice here I have negative 7u, and here I have du. So I'm going to solve the much simpler problem. Remember, that's the point of substitution, to solve a simpler problem. Okay, so the antiderivative here is going to be pull the negative 7 over, bump the power up by 1, and then 1 over that new power. And then don't forget your plus c. But then in the end, stick the original ugliness back in. So you would end up with that right there. All right, so how do you identify when you should be using substitution and when you shouldn't? The answer to that question is if you see that there's more than one part, especially if one looks like it could be the derivative of the other, then you need to use u substitution. So u is x cubed plus 5. du is 3x squared dx. Remember, that's just notation. We talked about that before. So on the one hand, this is u to the 1/2. And this, kind of combined with this, is du. Notice no adjustment necessary. So this is what I've got. I've got the integral of u to the 1/2 du. And notice how much cleaner that is, right? It's so much easier to do. Okay. So if you bump the power up by 1, if you take 1/2 and you add 1 to it, you're going to get 3/2. So it's 1 over the new power, u to the new power. And then don't forget your plus c. And then in the end, we'll find the reciprocal, but also stick the original back in. Okay, so we have the integral of x squared times x cubed plus 2 to the 10th power dx. So again, I think it's pretty clear what we would need to make u. You make u the inside piece. Okay, so du is going to be 3x squared dx. Notice that is not a perfect match for what I have. Here I have u to the 10th, but here I have x squared, but if I stick u in, I'm going to have 3x squared, so I don't really want that u, so you need to remember what adjustments we use, but this would be like 1/3 du. So instead, I'm going to solve the integral of 1/3 u to the 10th du. So bring the constant down, bump the power up by 1 and multiply by 1 over that number. Okay, and then add c. So this is going to be 1 over 33 times x cubed plus 2 to the 11th plus c. Because one more time, in the end, you stick the original back in. Okay, if it seems like I'm putting a lot of substitution problems on the review, it's because we struggle with that, and I definitely want you to know the difference of when you should be using it versus when you should not. Okay, the general rule of thumb is if you can think of 2 parts, then you probably have u substitution. So remember, we like to separate it out like this. If you're more confident, you may be able to do it without doing this middle step here. Okay, but I think it's helpful. So u, we're going to make 3 squared minus 1. So du is 6x dx. Okay, so notice, it's not going to be perfect, right? This is going to be 1 over u. That's our special case, remember. This is not quite right. If I put in du, I'm going to get 6 when I really wanted 3. So this will be 1/2 du. So this will be the integral of 1 over 2 times 1 over u du. So the 1 over 2 moves over, and then you take the special case, right? So it's the absolute natural log of absolute value of u plus c. So it'll be 1/2 ln of 3x squared minus 1 plus c. All right, last for this section. So 14. So we have the integral of x squared e to the x cubed minus 1 dx. So if you have an e problem, more than likely you're going to make u the exponent to that. du is 3x squared dx. So notice again, it's not perfect, right? But here we have e to the u. Here and here, kind of, we have x squared, but we don't want that 3 there, so we're going to do 1/3. Okay, that's the adjustment we need. So this is going to be the integral of 1/3 e to the u du. So constants get moved down. The antiderivative of e is just itself. That's supposed to be a u. And then plus c. And then in the end, stick whatever you originally started out being back in. All right, so definitely make sure you practice those. You're going to get more confident with these as you practice them. Okay, so let's look at 15. Okay, notice there is no need for u substitution on this problem. It's just a list of power rule type pieces. So this is going to be the integral from 0 to 2 of 2x cubed minus 3x squared plus 1 dx. So first find the antiderivative. So 2 pulls over, bump the power up by 1, multiply by 1 over the new power. Here we're going to get 3 times bump the power up by 1, multiply by 1 over the new power. The antiderivative of 1 is just x. So we want all of that evaluated from 2 to 0, or 0 to 2. So this is going to be 1/2 times 2 to the 4th, because 2 times the 4th is 1/2, minus 1/3 times 3 is 1/3 times 3 is just going to be 1. So minus 2 cubed plus 2 minus 1/2 times 0 to the 4th minus 0 cubed plus 0. But notice all of that ends up just being 0. So if you work all of this out, you end up just getting 2. Okay, remember you can check these on the calculator. I'm not going to show you that here, okay, but you can practice that on your own. All right, number 16. So notice how much more complicated number 16 looks than the last one we just did, right? Also notice it has more than one piece. So this is definitely a candidate for substitution method because it has multiple parts and because it's complicated. Okay, so let's see what we have. So u is going to be the bigger power thing. Okay, du is going to be 3x squared minus 6x dx. So let's talk about what I have over here. Here I definitely have u cubed. Here I'm not sure what I have, right? But let's go ahead and factor this out. So if I factor out a 3, because I really want it to look like that. So if I factor out a 3, I'll get x squared minus 2x dx. So notice I want it to be 12, but right now it's only 3. Okay, so what adjustment would I need to make? I would need to make 4 times du, right? Instead of there being a number I don't want, I actually want to make it bigger. And I'm also going to change my upper and my lower limits. So my upper limit currently is 0, but I'm going to change it into something involving u. So 0 cubed minus 3 times 0 squared plus 1. That's my new upper limit. My current lower limit is x equals -1. So I'm going to change that into -1 cubed minus 3 times -1 squared plus 1. So my new lower limit is going to be -3, right? Because I get -1 and then minus 3 plus 1. So it would be just -3. So here is my new integral. Bright and shiny and so much nicer. This is 4u cubed du. Look how much shorter that is than what we started with. Much, much shorter. Okay, so let's find the antiderivative. So 4 pulls over, bump the power up by 1, multiply by 1 over that power, and then we're going to evaluate it from -3 to 1. So notice in this one, these go away. So I actually just get 1 to the 4th minus -3 to the 4th. Okay, so if you work all of that out, you're going to get 1 take away 81, which is -80. Okay, what that should tell you is that most of the area is contained under the x-axis. Okay, but you can check that one on your calculator as well. Okay, notice in the definite integrals we don't ever plug u back in, right? Because we don't get a u in the end. Okay, we actually eliminate the numbers or the u's altogether. All right, so I'm going to rewrite this one as I go. So the integral from 0 to 2 of 1 over the square root of 1 plus 2x squared times 4x dx. So u is going to be the inside piece, definitely that part, right? The derivative is 4x dx. So let's talk about what I have. Here, just be careful. If it's on the bottom, it's negative, right? Since it's a square root, it's a 1/2. So here I have u to the negative 1/2. And here, notice no adjustment's actually necessary. I have perfectly du. Okay, so that's a nice change. But I still do need to change my upper and my lower limits. So my current upper limit is 2. So 1 plus 2 times 2 squared equals 9. So my new upper limit's going to be 9. My new lower limit, my lower limit's currently 0. But if I plug that into u, I'm going to get 1 plus 2 times 0 squared, or 1. So my brand spanking new integral that I like better because it's nicer numbers is the integral from 1 to 9 of u to the negative 1/2 du. Okay, so don't forget, after the rewrite step, you still have to actually do the derivative. You still have to add 1 to the power and multiply by 1 over that new power. Okay, if you add 1 to negative 1/2, you get 1/2. So it's 1 over 1/2 u to the 1/2 evaluated from 1 to 9. So essentially that just changes to 2. So it's basically like 2 times 9 to the 1/2 minus 1 to the 1/2. Okay, remember 1/2 just means, 1/2 power just means square root. So this is actually just 2 times square root of 9, which is 3, square root of 1, which is 1, or just 4 altogether. Okay, number 18, the integral from negative 1 to 0. Again, I'm going to split these up of 1 over 1 plus e to the negative x squared times e to the negative x dx. Okay, this one's a pretty hard one. Okay, it probably wouldn't be quite this mean to you on the test. Okay, but it's good to practice. So I want to make u the inside piece. Well, the inside piece is 1 plus e to the negative x. Notice the derivative of that, be careful, would be itself, but then times the derivative of the exponent, which is negative 1. Okay, so the derivative of this is actually negative e to the negative x dx. Okay, so that's probably the number one mistake people make on this one. So if I was trying to rewrite this, this is u to the negative 2. This is not perfectly a match for this. I actually want to get rid of the negative, so I can do that by either dividing by negative 1 or just multiplying by negative 1. Okay, so I have negative du there. So let's talk about what my new upper limit will be. So 1 plus e to the negative 0 power. Anything to the 0 power is just 1. So 1 plus 1 is just 2. But for the lower limit, we're probably not going to love what this is. Okay, but the lower limit is going to be u equals 1 plus e to the negative 1 power. In other words, just 1 plus e. So bear with me a little bit. We've got 1 plus e down here. I know you don't love that, okay, but we don't want to change it to a decimal. We won't get an exact answer. And then we want to take the integral of negative u to the negative 1/2 du. Okay, I'm combining these two together. So add 1 to the power. Notice if you add 1 to negative 2, you get negative 1. Okay, so move the negative out. 1 over the new power, u to the new power, evaluated from these little bit crazy limits. But notice this is gone. Okay, so you end up just getting 1 over 2 minus 1 over 1 plus e. Okay, the reason they're both 1 over, by the way, is because we get u to the negative 1. Okay, so it's actually just like 2 to the negative 1 plus this to the negative 1, which reduces to this. So if I wanted to know like what the area was, it would be about 0.23. Okay, in other words, not a large area at all. All right, so number 19, use the graph of the given areas to find the value of the definite integrals. Okay, so I'm not going to project the picture, but you've got it. Okay, so first I'm asking for the integral from a to b of 5 f of x. Okay, well, I gave you the integral from a to b if you look. Okay, notice from a to b, maybe I will show the picture. Notice from a to b, we're talking about region B. Okay, so region B, if you look at it, has an area of 2, but also notice where it is. Okay, it's under the x-axis, so it would actually be 5 times -2 or -10. Okay, the integral from b to c of f of x divided by 5 dx. And I forgot my dx notation here. Okay, so notice that would be the area from b to c. Well, that is area capital C, right? Like the third little section of area. So that's just going to be 1/5, because that's what divided by 5 means, times the area of C, which is 2. And I don't make that negative because it's above the x-axis. So 2/5 is what I get there. The integral from b to d of f of x dx. Now notice, I don't have b to d directly, but I can, let me show you the picture, I can go from b to c and then from c to d. Okay, remembering that this area is above, so it'll be positive, this area is below, so it'll be negative. Okay, so the area that's above the x-axis is the area C, which is 2. And then I'm going to subtract off the area under the x-axis between C and D, which is labeled as 0.6 in measurement, so we'd get 1.4. And then last but not least, I want the integral from D to 0. The direction of that is significant, of f of x dx. So if I were going from 0 to D, I would just add up everything. Okay, but I'm going from D to 0, which means whatever I get when I add them, I'm actually going to take the negative of it. Okay, that's one of our rules. Okay, so you might want to look back at, I think it's 12.5, the beginning of 12.5, or 13.5, not 12. So 13.5 is where you need to look. All right, so you're going to take area 1 minus area 2 because it's under, plus, so I should say area A. Area A is 1, right? Area B is 2 under the x-axis, so it's minus, plus area C, which is above the x-axis, so it's plus, and then lastly, area D is below the x-axis, so it's minus. So if you work all of that out, punch that in a calculator, you'll get negative 0.4. Okay, another way would be for you to just have added them all across and then just remember that you need to change the sign. Okay, so let's look at number 20. All right, the management of National Electric has determined that the daily marginal cost function is blah, 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 okay? And it's asking you to find the original cost function. So if I want to go from derivative to original, I use antiderivative to make that happen. So I know the derivative. What I want to know is what the original was. Okay, so always bring the constants down and then do the rule we talked about over and over, right? Bump the power up by 1, multiply by 1 over the new power. So I'm going to try something new. Rather than having like 2 terms, I'm just going to write this one over 3, but it's the same as saying this times a third. So I'm going to do the same thing here. So if I bump the power up by 1, I'll have 2x squared. Okay. Notice this always matches with this. This always matches with this. Always, always. And then plus 20x plus c. So if you work this out, you're going to get 0.00001 x cubed minus 0.015 x squared plus 20x. And then it does mention that the fixed cost is 500. Well, the fixed cost would be your c. In other words, it would be what would happen if you sold 0 coffee makers, right? If you did 0, 0, and 0, you'd have 500. Okay, so that's part of what it asks for, and then it says what is the cost function and the total cost incurred for 400 coffee makers. Okay, so just plug in coffee, I might need some coffee. Plug in 400 to that equation, okay, and I'll let you write all that out, but you'll get $6,740. Okay, so plug in 400 to these x's. All right, so the same company determined that its marginal daily marginal revenue function is r prime of x equals blah, blah, blah. Okay, and it's asking you to find the revenue. So again, we're trying to go back to the original from a derivative. So how do we do that? Q antiderivatives. That's how we do that. So this is going to be negative 0.03. If we bump the power up by 1, we'll get 2. Bump the power up by 1 here and you get 60x. Don't forget your plus c. Okay, so but if you really think hard about it, there can be a fixed cost. But if you're thinking about revenue, is someone going to pay you revenue for not selling anything? Probably not. Okay, so this is understood to be 0 for revenue. Okay, because while you can incur costs, and most of the time you will, for doing no business, you won't incur revenue for doing no business. Okay, so this would be the revenue equation. And then if I asked you to do our 400, okay, you're going to plug 400 into that guy, and you're going to get 21,600. Okay, by the way, you should be able to now tell me the profit for the 400th item, okay, because it would be this minus that. Okay, so let's do one more on this video, and then I think we'll do a second video, okay, for the rest of the problems. Okay, so 22, the market research for an automobile company estimates that the sales have a rate of that equation. So again, we want to use what we know the rate to be to backtrack and find the original. Okay, so if we want sales, we need to take the antiderivative of the derivative function that we know. So this is going to require a basic u substitution. So we make e the power. du would be negative 0.08. Okay, and then we can say dt. So let's go ahead and rewrite this. So I'm going to leave the 4. I'm going to leave a space here. Okay, I'm going to leave that we have e to the u du. But we need to get rid of that negative 0.08. We don't want it there. Okay, so how do you get rid of it? You just multiply by 1 over that unwanted number. Okay, this does actually work out nice as far as the number goes. So this is just going to be the integral of negative 50. Like if you actually work that on the calculator, it's just negative 50. And then what's the antiderivative of e? Just itself. But we also have a plus c. So we have the sales in general, but we still need to know what the c is. Okay, so if you read through the rest of the problem, it says that there were 0 sales at the time the car entered the marketplace. Okay, so in other words, when we plug in 0, we're supposed to get 0. Okay, so when we plug in 0, we're supposed to see an answer of 0. So this is where you don't just want to skip ahead and just say, oh, c is 0, because c is actually not 0 in this case. E to the 0 is 1, so actually c is 50, because negative 50 plus 50 would be 0. So the actual formula we want is negative 50 e to the u plus 50. And so if we want the sales, what does it say? What are the estimated total sales during the first 12 months? Okay, so we would find S of 12. So plug in 12 and you're going to get approximately 30.855 million. And then lastly, this is honestly just a review from Business Math 1. Okay, I probably won't put it on the test. I just want to remind you sometimes that you need to recall information that you did from the class before this one. So the last question says, how long will it take for the total sales to reach 40? Okay, so in other words, you need to use this formula properly to try to figure out what U would be. By the way, I also needed to have plugged back in U here. I notice now that I just didn't do that. So this would be negative 0.08t. I did it on the key, but I just forgot to do it here. Okay, so we want to know, when is this going to be 40? Okay, so this is just straight up Business Math 1. Okay, so we need to subtract 50 from both sides. We need to get the e term all by itself. So we have negative 50 e to the u equals negative 10. Divide by negative 50. Okay, so you can use decimals if you would like to here, but you're going to get e to the u equals 1/5 or 0.2, however you want to say that. And I don't know why I keep writing e to the u. Sorry about that. So I need to actually plug in what this is, right? In other words, instead of using u, I need to use the t. Okay, so now how do I deal with this? Okay, how do I get a variable out of the exponent? I take the natural log of both sides. So if this doesn't seem familiar to you, it's probably because it's just been a long time ago. It was from the class before this one. Okay. The point is that ln and e cancel each other out. They are inverse operations. So in the end, we just need to divide this by negative 0.08. So rest assured, you probably won't have a problem on the test where you have to necessarily do something just like this, but this is really just algebra. Okay, I'm just trying to remind you about it. So if you divide natural log of 1/5 by negative 0.08, you will get 20.112 months. All right, so make sure you practice the last half of the review and watch the video review too as well.